Cessna built the 177 Cardinal to be perfect, promising modern magic and a bold reinvention of the high wing, but something went so wrong that it embarrassed Wichita and turned what was meant to be a better Cessna 172 into a reputation nightmare that haunted Cessna for decades. To better understand why the Cardinal went horribly wrong, let's roll back a bit. In 1965, Cessna had already been the industry leader for 2 decades, building more than half of the world's GA products. And in the 10 years since they had introduced the 172 Skyhawk, about 11,000 of the 4-place singles had been built. It was already the world's most popular airplane. But the title of number 1 came with certain obligations, and assurance of continued business through R&D was one. There had been new features added to the 172, like the OmniVision rear window, aerodynamic cleanup, one-piece windshield, and the like, but both management and engineering were interested in the business and advanced design could generate. After all, the original 172 fuselage was basically a post-war carryover, and the wing traced its DNA to the 170A. So if Cessna was going to stay on top, it needed a modern wing and a cleaner airframe to sell the future, not just another refresh. Cessna also knew the market was moving. Piper was selling the idea of new, with cleaner lines and bigger cabins. Beech had the upscale image, and buyers were starting to expect more than a warmed-over airframe with a new window or a nicer panel. Management wanted something that looked and felt like the next decade. Engineering wanted a platform they could modernize and stretch across the lineup. And the sales team wanted an airplane that would make customers walk past a Skyhawk and point at the new one. In reaction to customer demand and a push for higher performance, Cessna engineers started looking hard at NACA laminar-flow airfoils. On paper, the drag numbers were gorgeous, but only if the wing stayed very smooth in real-world production. And the other big carrot was obvious. Lose the struts, and you lose a whole chunk of drag. That idea needed a proving ground, and the high-performance 210 Centurion was the logical place to try it first. Design work on the new cantilever wing began in 1964, and the first problem hit before anyone got to brag about speed. The main spar wanted to run right through the existing cabin structure, and its location didn't line up with the doorposts on the 210. To make it work, Cessna had to add a heavy supporting structure. That structure stole headroom, and headroom pressure triggered the next compromise immediately. The next obstacle was that because a cantilever wing is inherently heavier than a strut-braced wing, it normally requires a heavier main spar. Cessna was able to breach the problem at great expense by machining a tapered spar. Next, the wing was moved 4.5 inches aft for better visibility, but that created a nose-heavy condition and stability problems, the solution of which was a higher dihedral wing. Dozens of other compromises had to be made before it was test-flown in mid-1965. That was when it was evident that more elevator power was needed, and 6 square feet was added to the horizontal tail. A fully articulated tail had been considered, but was abandoned after testing. The cantilever laminar-flow wing debuted on the 1967 210G. Gross weight had of necessity grown 100 pounds, and cruise speed increases were a modest 2 to 3 miles per hour, although ongoing refinements over the next 15 years would eventually net an additional 20 to 30 miles per hour. Even though Cessna had spent millions in development, the 1967 models were priced virtually the same as the year before. It would take a long time to recoup the investment. But one way to get the best value for money spent was to spread the expense across several models, and the venerable 172 seemed to be a good place to start. Planning for a 1968 introduction, work was started on the 172J in 1965. It was referred to internally as the Jaybird, and security was tight. The new 172 would have a large, spacious cabin, better pilot visibility, more speed, easy entrance and exit through 47.5-inch wide doors, better flying qualities, tubular steel landing gear, and a modern, streamlined appearance. And, by management decree, it had to use a 150-horsepower engine for cruise efficiency. All previous flat-engine Cessnas had been powered by Continental, and the 172 had used the 145-horsepower six-cylinder 0300 model since its 1956 introduction. However, for some reason, Continental was abandoning its lower-power engines. Lycoming had a perfect candidate, and Cessna was so confident in it that they ordered 2,000 0320s before the 172J flight testing was finished, and they took an option on 2,000 more. To start with, engineers used the new cantilever wing design that was being introduced on the 67 Centurion, built with scaled-down component thicknesses for the lower target gross weight of 2,350 pounds. The wing skins would be thin, but the plan was to machine rivet the sections that would form the leading edges. However, factory manufacturing engineers rejected the scheme as too expensive, so even thinner aluminum was specified. The problem was that if the leading edge developed any dimples or waves, it would nullify the low drag potential of the laminar-flow airfoil. The maiden flight was made by test pilot Bill Robinson on July 15, 1966, and it showed that a great deal of development work was needed on the stabilator. Piper had been using the stabilator for quite a few years and knew its idiosyncrasies, but it was new to Cessna. Wind tunnel and flight testing showed that they had over-engineered it, and trim and anti-servo forces were excessive. In addition, the original 40-degree setting of the wide-span flaps produced a high rate of sink on final, so the maximum deflection was reduced to 30 degrees. The stall penalty was only 1 mile per hour, and landing distance over 50-foot obstacle increased about 50 feet. Despite its other good characteristics, the 172J wanted to drop a wing at stall. A high-camber airfoil section at the tip and a 3 degrees twist hadn't cured the problem, so 12-inch stall strips were installed on the leading edge, placed at a point on the wing that corresponded to the outer end of the horizontal tail. Flaps' retracted stall speed was 6 knots higher than on the 172H at the same weight. At maximum flap deflection, the increase was only 3 knots. The biggest problem showed up in an accelerated 1,000-hour service test, which included 5,000 landings flown by a number of pilots of different experience levels, and engineers found out that many were approaching with excessive speed and over-controlling and porpoising in the landing flare, often resulting in nose-wheel landings and wrinkled firewalls. It might prove to be a problem for owners to make the transition from elevator slow-pitch response to stabilator quick-pitch response. As changes and improvements were made, the weight of the prototype began to grow. One cure was reduction in wingskin thickness, which some wags were already referring to as spearmint gum wrapper, and shaving excess thickness of other parts. Eventually, empty weight came down to an average of 1,350 pounds, which is about 75 pounds higher than the 172. Time was running out. Early in 1967, a date was set for the introduction of the sleek new design in late summer. Soon after, it was scheduled to receive its type certificate. As the prototypes flew nearly every day, keeping them a secret became an obsession. No pilot was allowed to land at public airports or even fly low enough to be identified. But for all intents and purposes, the company did a good job of keeping it a secret from the public, and especially from the dealers and potential customers who might postpone a purchase until the sleek newcomer was available. Manufacturing began early, and plans for a lavish introduction were underway. Then someone asked a very good question. Let me get this straight. We're going to drop our best-selling model, the goose that laid the golden egg, so to speak, and replace it with a radically new airplane that's untried? The funny part is, this wasn't some brand new concern. On the factory floor, over lunch pails and coffee, the regular workers had already been asking the same question for weeks. Why are we messing with the bestseller? Why are we gambling the whole lineup on something unproven? They didn't have the big picture spreadsheets and boardroom logic the executives had, but their instincts were still sharp. So when that question finally got said out loud in the official room, nobody laughed, nobody brushed it off, the place just went quiet. The kind of quiet that tells you everyone knows the concern is valid, but nobody wants to be the one to say it. Finally, someone in charge broke the silence with an expletive that communicated the very same lack of foresight. Then, with an inspired expression, he presented Plan B. Okay, how many 172s did we sell last year? 1,600? We have 2,000 engines on order to cover this year's production and another 2,000 for next year, right? What say we build the new airplane, recertify it as the 172.5 or something, and keep the old Hawk in the line, powered with those other 2,000 Lycomings? That's not exactly how it happened, but that is what they did. Everyone got busy, deadlines were met, and overnight the 172J became the 177 Cardinal, and the 172 continued its charmed life as the 172I. About 1,100 Cardinals were sold at the Gala World Introduction in Wichita, where dealers were able to take same-day delivery on their new airplane and fly it home to show to customers. There was just one problem. As nearly every airplane took off from Cessna's delivery center, it popped into the air, then dipped back toward the runway and continued to porpoise over the horizon toward an uncertain fate. Not surprisingly, it was the same problem that had confronted service test pilots that was now being experienced by the people who were ultimately responsible for selling the airplane. A stabilator replacement program ensued, whereby a unit with leading-edge slots was installed to increase landing authority, but the damage had been done. The Cardinal had the sleek look of a crouching panther, but the speed and strength of a 4-week-old kitten, and the typical blanket damnation from pilots was, it doesn't fly like a Cessna. The net result of the year of the Cardinal was that after the deliveries of those first 1,100 aircraft, less than 100 reorders were booked. Cessna faced the reality that 150 horsepower was marginal and immediately set to work on the 177A with a 180 horsepower Lycoming 0360 E2D engine. It debuted in 1969 and furnished a modest gain in performance, 4 knots at cruise, 90 feet per minute more climb, and a much higher service ceiling. Everyone agreed it should have been the engine for the original Cardinal, but the cavalry had arrived too late to save the wagon train. Dealers still trusted the 172I, however. They bought 649 of them in 1968 and more than 2,000 over the next 2 model years. While the fixed-gear 177 suffered through another 10 years of mediocre sales, the retractable version, RG, may actually have made the whole program worthwhile. As it became obvious that the 177 was catering to an upscale market, engineers borrowed the technology from the 210. Using an electro-hydraulic system like the Centurion's, but with rear retracting nose gear, the 177 RG filled a vacant niche in the Cessna lineup. Gross weight was up to 2,800 pounds to accommodate the extra mechanisms, and the useful load remained just about what the 177B had been at 1,170 pounds. The RG was first flown in February 1970 and went to market as a 71 model. The sleek and modern shape of the basic Cardinal had been seemingly marred only by its down and welded landing gear, and the RG exercise produced a model that was competitive with the Piper Arrow and Mooney Ranger. With a 200 horsepower IO360 engine, the RG could cruise 80% as fast as the 210 for 60% of its purchase price, and of all the Cardinal models sold from 1968 through 1978, half were RGs. The Cardinal's fate was sealed the first time the first dealer struggled off the ground on that 90-degree day in Wichita and porpoised over the horizon. By the time he got home, he had found all of its real or imagined problems and unconsciously conveyed a distrust to his customers. As TV's Dr. Phil puts it, there is no such thing as reality. There's only perception. So that's it for today's video. Don't forget to like, subscribe, and ring that notification bell. It goes a long way for us.